Alright, so our second talk of the evening is by Tom Parrish from Crisp. Crisp is a Leeds-based company full of bright people, really great company. I've had many chats in the pub with them. It sounds like a really fun place to work. So I'm looking forward to this because I don't know much about C#8. By the way, I forgot, we always give you a chance to big up your company, so if you want to shout out your company, it's always nice to hear who you're representing. Anyone? Yorkshire Water we had, or Crisp? No? You don't want to?
Black Light Software.
Pardon?
Black Light Software.
Black Light, okay, yeah, well that's a regular. Alright, well, without further ado, Tom Parrish.
Thanks, Matt. Hello, everyone. As Matt mentioned, I am Tom Parrish. I'm a developer at Crisp Thinking, and I'm going to talk to you about some of the proposed features for C#8. Obviously, don't have a release date yet for C#8, so I can't give you, these are the things that are going to be in it, but we can go over the things that are looking like they're good prospects. So, a bit of a summary of what we're going to be covering. That's minuscule. You can't read that at all, can you? The other slides are bigger. So I'm going to cover 4 of the big features first, 4 of the larger proposals. Then I've got a couple of other smaller things, and basically I'll fit those in wherever I can. And finally, I'm going to talk about where I got the information for this proposal, for this presentation from. So, first feature, default interface methods, also known as traits. So let's take a really simple interface. We've got an interface here that represents a message that we can log. It's just a simple logger interface, but like many other interfaces, we might want to grow this over time. So we've got a couple of implementations for it, and say we want to add another method to it. Say we want to add a method to this interface that allows us to log a message and an exception. Now in C#7, we've kind of got, we've got a couple of ways we could add this method to the interface. We could obviously add it to the interface. Now, the problem is if we add it to the interface, then all the classes that implement that interface will get broken, and they'll have to implement that interface, that method, before we can compile them again. Alternatively, we could actually add an extension method rather than alter the interface, which is great, because then all the clients of our iLogger interface can immediately start using this implementation. But if we wanted to change that behavior for any of the subclasses of or implementers of our iLogger interface, you can't. So what we need is a means of being able to declare this method and provide a default implementation. Hence the name, default interface methods. And that's a syntax that we propose to get in C#8. So here it is. So what it is, you have an interface, and in it you have the declaration of the method and also what is being referred to as the default implementation. It's a method, essentially. Now, because it's a default implementation, they are all implicitly virtual, so you could override them. So let's take a look at how you would do that. It's largely as you would expect. You use the override keyword, and you can provide your own implementation in there as well. Now, that's largely all well and good, but say if you've got like a class of logger that the default implementation didn't really make sense for at all. Say if we have like a database logger. Now, there's loads of useful information in a stack trace, and it would seem a bit silly to go and take that exception data and then write it as text into a database field. We probably want to do something a bit smarter with it. So what we can do is we get a concept called re-abstraction in interfaces. So you can just redeclare the same method signature again in a sub-interface and mark it as abstract again. That way, things that implement that interface are then required to implement that method as well. So we could say if this was our base class, we could then have subclasses of this that would have to implement that method as well. So you just change the interface. So the next feature is lightweight classes. Now, lightweight classes are a means of reducing the boilerplate and the volume of code that we always have to define on model objects or just classes in C# generally. Let's take an example of a very simple class. It's just a point, just represents a point on a graph with an x and y coordinates. Now, all well and good, but if we look at the class, there's only really a couple of points that we're actually sort of conveying information. So we know it's a point because we call the class point, and we know it's got an x and y coordinates because it's got some properties called x and y. But then we have a whole constructor again that declares point again, and then we have x and y and x and y and y and y and x and y and y and x. We don't really need it. And we have to do this if we want to just get this basic functionality of having a class which represents two properties. So, as you might expect, this proposal is going to give us a more succinct syntax for declaring this. Look like this, and they're going to be called records. So the record syntax is this bit between the braces where you declare your read-only properties. So you have two properties on this record, x and y. They're both implicitly read-only. So you may recognise this syntax from a proposal that occurred in C#6 called primary constructors. It never actually made it into C#6 though. The proposal got capped. Now it's back again because there are some developments that we got in C#7, which means that this proposal can offer more things. So as well as getting like a constructor as you see here and the properties, the read-only properties that you'll get by default, we'll also get something called a deconstructor built for us. Has anyone used deconstruction in C#7? Right, so basically it's a means of allowing us to take an instance of a class and pull values out of it without the need to assign local variables. So here we're assigning our local variable x to origin.x. So here, this is a deconstruct syntax, and that's basically assigning var y and x by calling a deconstruction method, which basically says you define it as a method inside in the class, and it says when I call this deconstruct syntax, which basically is just these braces, it can pull out two variables and we can assign them to whatever we need there. So these classes, the record classes will have a deconstruct method on them. Normally, if you wanted to implement deconstruction in C# as of C#7, you would have to implement a deconstruct method. You don't have to do that with these; they'll come with it implicitly. In C#7, it's available by default on tuples and value tuples. Now these classes will be read-only, so if we want to modify them, well, you can't. So there obviously we are going to have situations where we do want to modify them. So they'll all come with a method called with, and that will allow us to modify it by copy. So say we've got our origin here, which represents the point 0, 0. You can call this .with method, and you can pass in the names of your properties here, and then you'll get back a copy which has got the properties you passed in assigned, and anything else you didn't specify will be what the original was. Now we might get that as a method, or we may get it as a keyword, and there's various discussion about sort of like how we can merge in partial objects and nested objects. That stuff is definitely ongoing in the proposal at the moment. So you're all dying to know what happens is if you specify struct instead of class for a record type. So the struct obviously is a value means that you're declaring a value type, and that has some slightly different semantics to it than like a class. A reference type would be considered equal by reference. A value type would be considered equal by value. So if you declare a struct class, you will implicitly get the equals methods implemented for you with sort of like the default implementations that look at your record properties. So those are kind of, that's the record stuff. The bit where it starts to get more interesting is advances in pattern matching. Now pattern matching is started to come to life really in C#7. it's a load of syntaxes that allow us to start to match against variables and do things with types. So here's a recap of the features we've got in C# 7 for pattern matching. So this is the first pattern matching syntax we've got, well, one of the most used ones, and it's called a type pattern. Is this familiar to anyone? Yeah, cool. So basically what this is saying that this if statement is only going to be true if the value is point and we can assign it to this point variable. That's kind of the point, the extension that we got from in C# 7. C# 6 still had the is keyword. Also, we have the default pattern. Now this is a very strange looking if statement, because usually if you're in an if statement you would be doing if value equals null rather than is null. But the syntax that was introduced in C# 7 is highlighted here because you can do is null, which is basically saying is equivalent to the default value for this type. It doesn't make much sense in an if statement. It makes a little bit more sense if you look at it in the case of a switch statement, where we've got a type pattern here doing something with points on the zero plane, something else doing something else with points that aren't on the zero plane, and here the case that matches the default pattern, which is not the same as the default case. The default pattern is matching the default value, which is null. So here you could say, give me some specific value handling for null, and the default case would be any other value. You do stuff there. So in C# 8, the proposal includes 4 new patterns and a whole class of pattern types. So the new kind of pattern is called object patterns. So let's go over those first. Object patterns will give us means to access the deconstruct syntax we spoke about earlier as a pattern. Well, this example does. This is the positional pattern, and that basically allows us access to the deconstruct. So this is going to say this value should, this if statement should only be true if the value is a point, and if it is, then we assign the values we get back from the deconstruct method to x and y. The deconstruct method returns multiple values by having lots of variables defined. So yeah, here we can see basically we've got 2 patterns in here. We've got this bit here with the braces around it. That is the positional pattern, and inside there you've got more recursive patterns, which are in this instance type patterns. But you could kind of just recursively do this and keep on going down and down and down. Similarly, so you have a property pattern. It says, oh, there we go. There. So property pattern is going to allow you to match against the properties on a class. So the properties would be, say, something like the x property or the y property. So this if statement is constrained by a property pattern, and that is basically saying that it's only true if the value is a point and the x is an int, which in this case it obviously is going to be because x is an int, but x could be an object, so that would have meant that this if statement wouldn't be true. And if it is an int, then we assign it to x, and if y is an int, we assign it to y, and then we go into our if statement. So the type pattern there is a bit of a cheat because, well, we're not actually pattern matching. There's no conditionality to it. It's always just assigning values to a variable. So these are what are commonly going to be referred to as object patterns. They'll provide us this kind of recursive syntax and allow us to do some really smart things in some kind of pattern matching and recursive functions. So we will also be getting some value patterns as well, and this is where we'll kind of be able to do some more useful things around the values that we're actually inspecting. So this is the var pattern. The var pattern, very similar to the type pattern, except it doesn't have a check for a type. So the actual syntax that we're talking about here is this bit here, var x inside this bit. And basically what that's saying is this is a pattern that always matches, and it assigns your variable that comes back from this pattern to the variable x. And rather than the type pattern where it's going to say, right, that it comes back as this type, it comes back as the implicit type of whatever the compiler can figure it out to be. So in this case, we are assigning x and y to be integers because we know that that's what point contains. But say if they were collections, then we would have a massive, huge, long line here with collection names and I enumerable several times, and it would make the line very long. So hence why they've added var, just to make this kind of code a lot more succinct. The thing that we can use to start constraining our patterns is something called the constant pattern. So this is a pattern that says this if statement should only be true if the value is a point, and when we call the deconstructor, the value we get back from the first position is a 3. And if it is a 3, then we carry on and match the rest of the patterns, and we actually get those variables assigned. Cool. So let's have a look at a slightly more involved example. Here's a switch statement that is calculating the area of a shape. So we've got 3 different kinds of shape: rectangle, circle, and point. And we use like the property pattern here to pick out the width and height, so we can easily calculate it there. And circle, we just use the type pattern to pull out a circle variable. But what this switch statement is doing, as many switch statements do, is calculating the value for an area in 3 different ways and assigning it back to this variable, which is it could be done a little bit more cleanly. It could be nice if like this switch statement could be used as like you could have a value you return from this, which is part of the proposal. So spoiling my phone. So the switch statement will be raised up so that you can use it in a slightly different context. So you can use a switch keyword after a variable, and that will basically be you can get a value back from your switch statement. So each of these cases will return a value based on which is the one that matches. This is actually not valid C# because it should have a default case in there, because if you're going to return a value, you kind of need to have a value returned in all cases. It can't. If none of these matched, then it would have to hit the default case. So that actually wouldn't compile. But what it would generally do is each of these case statements would calculate a value, and then that would be assigned back to the area variable. Also, the let keyword, that's actually from a completely different proposal, but I put it in there as an example, and that's a feature that's been stolen from F#. It's basically going to allow you to declare a read-only local variable, which at the moment you have to use the read-only keyword, which is quite long. This just allows us to very quickly to declare read-only variables, which doesn't really make much difference to us, but for the compiler and runtime, it makes life a lot easier. They can do a little bit more optimization. So, next major feature is nullable reference types. Has anyone heard of nullable reference types? Yes, I thought many people would have heard of these. This is kind of the headline feature of C# 8. To get a bit of background on this one, you kind of need to understand the difference between value and reference types. So value types are things like integers and doubles. You can't have a null integer. It's not a thing. If you want a null integer, you have to have an int, which is int ? That's called a nullable reference type. Let's call them ints. So the problem is with reference types, things like strings and classes and lists and all those kind of things, they can always be the type or null. With a reference type, it's always whatever it was or null. So this presents us with some slight conundrums. So if we look at this code, we know that if we ran this, we'd get an error, because we're assigning a variable greeting to a string, then we're assigning it to null, and then we're calling a method on null, which we can't do. But for some strange reason, the compiler can't tell us that this is a problem, when it really obviously is. So what this proposal is going to do is add a means for us to make that something that the compiler can detect. So the first part of the proposal is quantifying the areas where you could be null. So we're basically going to get the nullable syntax extended. Oh no! Nullable syntax extended into reference types. So you can declare a string, and that would basically say this could be a string or it could be null. And it's at that point that you can actually start saying, right, okay, well, the compiler will say you have to treat this as if something that something that could be null. If you don't check for nulls, then I'm going to start giving you warnings that you haven't checked for null. So you'll get the same syntax when you try and access values from it as you do with nullable value types. You have to use the .hasValue and .value methods, which could get a little arduous. So we are going to get the rather beautifully titled dammit operator. You can see down here, yes, it's called dammit, brilliant name. You just use exclamation mark after the variable name, and that just says, I know what I'm doing, you don't need to question me, it's not null. So that's that side of the proposal, but you still got the problem that the default case, when you don't have a question mark on it, those reference types can still always be all null. They can't change that behavior, because if they did, huge swathes of everyone's code base are suddenly going to stop compiling. But what they can do is start to nudge us in the right direction by providing code warnings, which is exactly what they're going to do. So here's an example I've stolen from a C# corner, I think, and it basically shows you the new warnings that we'll be able to get in Visual Studio to indicate when we haven't initialized like non-nullable reference types. So here we're going to get warnings for user ID and name, because we've declared these as string, and we declared them in this class here, but this class doesn't have a constructor. So when you create an instance of user ID and name will be null, because they haven't been initialized in the constructor and they don't have any default values. So you get these warnings now saying that's going to be uninitialized. You didn't say it could be null, so it can't be null. The idea being that as you write new code, you can start turning these warnings on and saying fail on these as warnings and turn them into errors. So it's not something that we can introduce wholesale into a code base, but we can start to hint on it and slowly move away from the kind of the places where there's almost certainly going to be places in everyone's code bases where we are not handling null correctly, and we won't know about it until we start to look at these kind of warnings. So the last major feature I'm going to talk, yes, this is the last major feature I'm going to talk about, is called Asynchronous Streams, which has nothing to do with the Streams API at all. It's in fact a mechanism for handling asynchronous collections, collections of values, and multi-threading much more cleanly together. So a feature we got in C#6 was the ability to have a method that looks like an IEnumerable. So we could use the yield return and yield break keywords to make pretend that our method is a list of numbers. So here we're calculating the Fibonacci sequence by returning values using this yield return. So that means you can just access values in a for each loop using this by calling this method, but you don't actually have to allocate all the memory in the world to store the whole Fibonacci sequence. It'll keep on going through this until you exit out of the for each loop or stop calling move next on your IEnumerator. So that means we can do like sequential generation rather than things where we actually have a fixed size of collection. But the big problem with these methods is that you can either use the yield keyword or you can use async await. You can't use both. Well, the reason this is that the compiler team had not written a state machine that represented the complexity of doing things asynchronously and this yield return. That they have. This is a thing that they've now done. So we could say take our Fibonacci sequence and then we can call it in a method that does asynchronous await stuff, and we can do both at the same time. So we can call yield return and call await in the same method, and everything's wonderful. Now, the strange thing about this is that it's not returning a task. It's returning an async enumerable, which obviously all our asynchronous methods have usually returned tasks up to this point. Well, this is a new API that we're going to get to allow us to kind of model this asynchronous collection. So it's very similar to the IEnumerable interface. Here it is. There's two parts to it. The async enumerable interface, which is essentially only really there to allow us access to the async enumerator interface. And the bit where we actually get the asynchrony introduced is this bit here, where our move next method is now move next async and returns, oh dear, and returns a task of bool rather than just a bool. So that's where you would do. That's where our native syntax, which we'll get to look at in a second, that's where our native syntax will implicitly await this task. Now, something to note about this interface is there's no way of cancelling this asynchronous operation. Now, we'll have to look at the Fluent syntax to explain why there's no means of cancelling this operation. So this is the syntax that we'll be getting for each await. So it's a means of looping over this and calling that move next async. Implicitly, all the awaiting is done for us, and then we just kind of get back our value. Now the reason that they didn't include cancellation tokens in the actual interface is that, well, the cancellation token would have to change on each iteration through the loop, because move next async is going to take a cancellation token potentially, or maybe you pass it in when you call get the iterator. The idea being basically you're in a for each loop. If you want to cancel out of it, you just observe the cancellation token in the for each loop. And if you want to abort the collection generator, you just pass the cancellation token into there. There's no point trying to shoehorn a cancellation token into a language construct that has to be understood by a for each loop. It's not something that is really going to benefit this proposal. So, all well and good, we get this nice for each syntax, but who here has used RX or the reactive extensions? Okay, so reactive extensions are basically a means for doing something very similar to this. They allow us to asynchronously process collections of data. And there's a lot of discussion about whether this is going to be a replacement for this, but realistically it's not, because RX provides kind of the same kind of API surface area as all the link extension methods do. So you've got select and where, you can do it asynchronously. This proposal doesn't include any of that, so you're just getting a for each loop. I'm sure that there will be community efforts later on to add link methods to it, but they looked at the number of link methods. They were like, there's 273, we've got to test them on all the platforms that we support. And they just gave up on that at that point. However, there is one benefit that we get from this, and that is, so if we just take a look back at the API, you can see here on the enumerator interface, this iasync disposable interface that it also implements. Now, that's it's a bit of a strange thing for that interface to implement, but basically it's a mirror of the iEnumerator interface. The iEnumerator interface implements iDisposable. Now the reason it does this is because in our methods, when you're looping around and you for each loop, you call move next for you, you might have a finally block in there that you're expecting to be run in your backing method. When you exit out your for each loop, whether you finish the loop or you break early, then the enumerator is disposed, and that goes back and calls your finally block. Now, it was fine for iEnumerator to implement iDisposable because we knew that the finally methods in the old school iEnumerable methods didn't have any asynchronous code in them. They didn't have any await keywords in there because you weren't allowed to mix yield and await keywords. Whereas now we've taken away that constraint, so we have to expect finally blocks could contain asynchronous code. So we have to have an iasync disposable method, which will look like this, and will be obviously available for us all to use on our own code. So if you're like using statements, then you'll be able to use this as a complete drop-in replacement, and if you're doing something asynchronous, you'll just be able to use it in a using statement in exactly the same way. It will kind of await the task for you at the end of the using statement, which might potentially mean you're hiding a task or something, but in terms of simplicity of code to understand, much better. You might notice again that once again there's no way of cancelling this. Now the logic behind this one was slightly different, and I can empathise with it, is that you don't really want to pass a cancellation token to the cleanup because it's cleanup and you can't cancel cleanup. As much as my children would like to cancel tidy up time, it's not an option. So that's the main big feature. The last little thing I'm going to talk about, and these kind of a pair of little features, but they're really nice, is something called the index syntax. So this is quite a smart proposal because basically it builds on something we do an awful lot in C# or in a lot of code bases, is indexing into arrays of numbers by the index number. So if you've got an array of values, you might start at 0. There's plenty of places in many code bases where we're accessing the array.length minus one element to get at the last element. This is going to give us a means for expressing that much more succinctly. So here you can see we've got a little hat operator. That basically means the first element, if we started at the end and went that way, instead of starting at the beginning and going that way. So you can get the last element out that way. And you can also access it as an API to be able to create index objects. All these indexes will be index objects rather than just straight numbers now. That works quite well, but it gets more powerful when you combine it with a new range syntax. So say you've got a list of numbers, we'll be able to get a subset of the numbers out of it using this a new double dot syntax. So say there's a couple of different ways of using it. You might start by saying I want a starting index, and I want all the elements from this index to the end. So here we're saying I want all the elements from index 1 to the end of the array. Or reversing it, you could say I want all the elements from the start of the array up to index 2. So that would give you the first two numbers. You can combine them both together. By using they are index syntaxes, so you can do I want the elements from index 1 to index the penultimate. That will give you 2, 3, 4. Because it's an index, you can just like use that hat syntax to say work from the end, please. Or you can just have none of them at all and just get a copy of the array back. So you can just call list ... and that'll give you a copy of the array. Now, not quite sure what that means. The proposal doesn't really quantify whether when you say a copy of the array, is that going to allocate a new array and copy all the values in memory? Is it going to give you a link style representation of it? Is it a span style thing? It's as far as this proposal goes, it's a copy, whatever that is. Cool. So that's really the features. Let's talk a little bit about where I got all this information from. Well, like many programmers, I get all my answers from GitHub. It's not on Stack Overflow, it's on GitHub, this one. So if you go into the .NET repo on GitHub, you will find a very nicely curated set of issues that represent all of these features with very active discussion around them. The kind of a process whereby they're proposed, they're tagged for different releases. So obviously, some of these features are really big. They're not going to fit into a GitHub issue, which is very good for debating, but not so great for speccing things out. It's sort of like when you're talking about language constructs. So those get moved into a proposal document, which you'll also find in the same repository. That's basically a living document that evolves and kind of includes details about everything to do. So this is the pattern matching proposal, and it's got like a breakdown of the exact syntax that will be valid for each of the different types and different patterns that we'll be able to use. And those kind of evolve as the proposal carries on. Yeah, and that's there. If you also, the other thing, if you go to those repositories, you can download some preview builds of the default interfaces. You can download .NET Runtime and SDK that support that, and the indexes and ranges. There's a preview you can get for that, which you can install in your work computer and break. And also another one. There's one other preview you can go and install on there as well. And that's about it.
Have you downloaded the preview?
No.
Have you had a play?
I'm too scared. Yeah, I was going to download it, then there was lots of warnings saying this is going to break your computer. And I was like, okay.
Any more questions?
So you may not be able to answer this, but what would be the difference between the range operator and creating a span of your...
Well, the range operator says it will operate on the data type, so it's a means of, the proposal basically includes arrays and iLists, and that will return an array and iList. So it's not going to transform the data type. It says that it will kind of maintain, it's a bit woolly around what data type it's going to return, but it's primarily for arrays.
Do you know what the motivation behind the advanced pattern matching is? Is that because of the AI side? Is it to put behaviour to data?
I'm guessing it's sort of like it is. it makes code a little bit simpler. I think a lot of the features that we're seeing develop now are being picked up from the existing features in F#, where pattern matching is a very prevalent pattern in F#. And I think they're trying to work towards more of a discriminated union kind of thing. So if you look at like the pattern matching proposal, you can see that they're kind of trying to give you a situation where you can like easily fork on different types. So yeah, I think that they're taking a lot of inspiration from those kind of like more functional languages, trying to bring the best bits of functional languages into C#.
Right then.
Alright.
Thanks, Tom.
Yes.
Just before we go off to the pub, I hope you all join us in the pub